Welcome to The Explainer. Today, we're going to talk about how to supercharge your learning. It's all about finding that perfect sweet spot, the Goldilocks zone, where things aren't too hard, not too easy, but just right for you to really get into it.
All right, let's just jump right in. Think about this for a second. Have you ever been trying to learn something and it was so easy you just drifted off? Your mind just wandered? Or what about the opposite? You're faced with something so incredibly hard that you just think, nope, not even going to try. You just want to walk away. Well, guess what? That feeling, it's not just you. There's actually a scientific reason for it, and it's exactly what a really cool 2024 study from Tina Sufert and her team looked into. They wanted to find the key to making learning way more effective by figuring out this exact balance.
So, Section 1, the learning sweet spot. What we're really looking for here is something that researchers call the zone of optimal self-regulation. It's basically that perfect level of challenge, where what the task is asking of you is perfectly matched with what you can actually do.
And this whole idea, which Sufert actually first talked about back in 2018, is really the heart of what we're talking about today. See, it's not just about gritting your teeth and pushing through something that's super hard. The real magic, the real learning, happens when you find that perfect balance, that equilibrium between what the task demands and, what you've got in your toolkit.
All right, Section 2, 3 key ingredients. So, if we're going to find this balance, how do we do it? Well, the researchers zeroed in on 3 key ingredients. And these things are always playing off each other when we learn. If you can understand these 3, you've pretty much cracked the code.
Okay, first up, we've got self-regulated learning. The best way to think about this, it's your personal learning toolkit. It's you consciously deciding how you're going to tackle something. So instead of just passively rereading a chapter for the 5th time, you're actively doing something like, okay, I'm going to make some flashcards, or I'm going to draw a mind map to see how all these ideas connect.
Second ingredient, cognitive load. This is basically the mental effort a task costs you. Think of it like this. Your brain's working memory is a lot like the RAM on your computer. If you try to run too many heavy-duty programs at once, say you're trying to wrap your head around a brand new math formula while also trying to memorize all the different parts of it, what happens? Your whole system just grinds to a halt. That's high cognitive load in a nutshell.
And number 3, you've got your learner resources. This is everything you bring to the table before you even start. It's all your personal assets. So if you're diving into, astrophysics, your resources aren't just what you already know about physics, it's also how jazzed you are about space. It's your motivation, your confidence that you can actually handle the tricky math. It's the whole package.
Now, this is where it gets really interesting, because these 2 things are like competing forces. They're constantly in a push and pull. Think about it. As a task gets harder, the cognitive load, the mental energy it takes, goes way up. But at the exact same time, your personal resources feel like they're shrinking. All of a sudden, the knowledge you had and the motivation you felt just doesn't feel like it's enough anymore.
Okay, Section 3, putting it to the test. So to see how all these ingredients actually work together in the real world, Sufert's team set up this really clever experiment. And they did it in a real school, which gives us this amazing window into how this stuff actually plays out for people.
Here's what they did. They got 67 11th graders to take 4 different exams. These tests had a whole range of difficulty, from something pretty straightforward like English or German, their native language, to something tougher like math. And here's the key part. After every single exam, they asked the students to report back. How tough did it feel? What resources did you feel like you had? And what specific strategies did you actually use to get through it?
Section 4, the U-shape of learning. And what came out of this experiment was, well, it was brilliant. It showed this super clear, predictable pattern for how we all use our learning strategies when things get harder or easier.
So this brings us to the big question, right? What exactly did they find? You'd think that as a task gets harder, we just try harder, right? We just throw more and more strategies at it. But it turns out the answer is way more interesting than that.
What the data showed was this really clear inverted U-shape. Specifically for those cognitive strategies, the how-to stuff like summarizing or organizing ideas. When a task was easy, students didn't use many strategies. When it was moderately difficult, bam, strategy use shot way up. But then, and this is the fascinating part, when the task got really, really hard, their strategy use dropped right back down again. And when you think about it, this makes total sense. On the one hand, if a task is super easy, why would you bother using a complex strategy? You just don't need it. But on the other hand, when a task is overwhelmingly hard, your brain is in full-on survival mode. It's using every ounce of mental energy just to keep its head above water. There's literally no bandwidth left over for anything extra, like fancy learning strategy.
But wait, there's a twist.
Because it turns out not all learning strategies work this way. The researchers discovered a totally different pattern when they looked at our higher-level strategies, the ones we use for planning.
So while we stop using those hands-on how-to strategies when we get overwhelmed, something else happens. The use of what are called metacognitive strategies, that's things like planning your next move or checking in on your own understanding, that just kept going up and up as things got harder. It didn't drop off at all. It's like even when our brain is totally overloaded and can't do the complex work, part of it is still trying to plan a way out of the mess.
Okay, Section 5, Finding Your Goldilocks Zone. So what does all this mean? What's the big takeaway for you and me? How can we actually use this stuff to get better at learning?
The big message from all this research is pretty simple, actually. The absolute best, most effective learning happens when you're in that sweet spot of moderate difficulty. That's the zone where everything is in balance, the task's demands, and your own personal resources. And it's where you have the mental space to actually use your best learning tricks.
And the best part is, you can actually look for this zone yourself. Try to find challenges that stretch you a little bit, but don't completely break you. And be honest with yourself before you start. Do I have the background for this? Am I motivated? If you start to feel that sense of being totally overwhelmed, that's your cue. It's a sign to step back and simplify the task. And hey, if it's way too easy, find a way to make it more interesting. Add a little complexity.
At the end of the day, what this research really does is it invites us to just be a bit more mindful about how we learn. By consciously trying to find that personal Goldilocks zone and staying in it, we can make learning so much more efficient, way more effective, and honestly, a lot more fun. So I'll leave you with this question to think about. What's in your learning sweet spot?